So we are going to use a tabular method to compute this convolution sum. Now, to use a tabular method, I'm going to write the data for x as a sequence. So x of n will be equal to -1, half, 1, and minus half. Now I need to indicate where the origin is. So this is n equal to 0. And then I'm going to write h also as a sequence. So I have half, I have 1, I have negative half, and half, and this corresponds to the origin, n equal to 0. So the first step, step 1, for this tabular method is to put the data in a table. So I'm gonna make a table and I'm gonna put x and h in that table, and then we're going to continue from there. So I'm gonna make a table here. So I have 1, 2, 3, 4 element in x and 4 element in the y, in the h. So let's see, I have 1 and 2 and 3 and 4. So 1, 2, 3, and 4. So I am going to put x in here. Doesn't really matter. So n, let's say h of n in here. So the value for x are -1, half, 1, negative half. The values for h are half, 1, negative half, and half. Now, when we write a convolution, it's a product, right? Sum, okay, from -infinity to +infinity, x of n minus k, h of k, for example. So we're gonna multiply the h and the x, and then we're gonna add them up. So when I take half multiplied by -1 is negative half. Half times half is 1/4. Half times 1 is half. Half times minus half is minus 1/4. Then I take 1 that multiply this, -1, half, 1, negative half. Then negative half times -1 is half, -1/4, negative half, and 1/4, which is negative half times negative half. And the last one, so 1/2 times -1 is minus 1/2, and then 1/4, and then half times 1 is half, and half times negative half is minus 1/4. Okay, so that is our table. So I'm gonna copy this table. Okay, so what are the next thing we need to do? So the next thing is to add. So in step two, we're gonna add the of diagonal data. So that means you have y of n. You can already add a sequence. So the sequence is kind of long, so I'm gonna start from here. So the first data, which is this, just negative half. And the second one, which is -1 plus 1/4. So minus 0.75. So minus 3/4. Minus 3/4. Then this one is half plus half plus half, which is 1.5, which is 3/2. Now this one is minus half minus 1/4, so that's minus 0.75 plus 1, which is 0.25. Now plus minus 0.25, that should be 0. So that's 0. And then this, which is -1 plus 1/4, which is negative 0.75, so minus 3/4. Okay, so the next one is minus half plus 0.75, 0.25 is 3/4. And the last one is minus 1/4, is this element. Now we need to find where the origin is. So for x, the origin is right there, right, which is n equal to 0. And for h, the origin is right there, that corresponds to n equal to 0. The first element is where the origin is. So when we look at the intersection, they will both meet here, which is the second data in the table. Okay, so that will correspond to n. That's the second data in the sequence of y. So that corresponds to n equal to 0. Okay, so we can write y of n as -1/2 delta n plus 1, because that's the data right before 0. So minus 3/4 delta of n plus 3/2 delta of n minus 1. That's 0 delta of n minus 2 minus 3/4 delta n minus 3 plus 3/4 delta n minus 4 minus 1/4 delta n minus 5. So that is y of n. So when you convolve x of n with y of n with h of n, that is the result. So this is what we are looking for. So the tabular method is quite simple. So the steps are: put the data as a sequence, put them in the table, and then once you have the table, then you can just multiply the data, and the next step is to add, and then to locate where the origin where the origin is, or you can reference any other data point like n equal to 1 for both x and h. But my recommendation would be to locate the origin, and then you go from there. Thank you for watching.